Okay, hello, my name is William Liu, and I'm going to be demonstrating my little network with two routers and two hosts. So right here we have R1 and we have R2, which are our routers, and then we have PC1 and PC2 as our host. So right now in the topology over here, you can see that PC1 is connected to the router 1 via Ethernet Ethernet 0, and R1 is connected to it via fast Ethernet 0/0, which is the interface for that router. And similarly, R2 will also have fast Ethernet 0/0 as an interface, and then PC2 is connected with Ethernet 0. So that's what's going on in the topology. And then we have our router 1 and router 2 connected via a serial connection, which is going to be 1/0 and 1/0. So they're connected through that serial connection. Okay, I'm going to go ahead and start booting these guys up. All these devices should turn on. And then when I click on console, ooh, that's a bit weird. There we go. We have our PC1, PC2, and then we have our router R1 and our router R2. We can ignore all this stuff. And then we can get started. Let's try. I'm going to try to ping an R1. I'm going to try to ping. Oh, before I start pinging things, let me just show what we are working with. So in R1, we have set the fast Ethernet, or FA for short. I'm going to just go FA00 as a quick way to say it. So the FA00, we've set the IP address right here. I've done this configuring on my own time. I'm just demonstrating right now to 192.160.101.1, and that's the subnet mask for that. And then we also have serial 1, which is the IP address is right here. Right. And then we also have our subnet mask. Same thing goes for R2. We're going to do show running to show all our connections. FA00, the IP address is right here. It's different from R1, so this one ends with 102.1, while R1 ends with 101.1. And then the serial 1-0 IP address is right here. It shares the same network as R1, so these two right here, these two routers are part of the same network. They also are in the same subnet, which I'll show in a little bit. If I remember the command, it should be what was it called? IP route. Oh, show IP route. That was the command. So as we see here, serial 1-0, the IP address ends with 100.1, and as you can see, R1 is connected to that subnet. This is the network address of that subnet with the subnet mask of 30 bits. And then we have this right here, or this shows us what the subnet is, and then this right here is the subnet address, or the network address of that subnet. As we can see, R1 is connected to it, and it's also connected to this subnet, which is the subnet for the fast Ethernet. Then we go to R1, we're gonna do the same thing, show IP route. And as you can see, right here, this is the subnet, and this is the subnet address. As you can see, it's the same, it's the same network address. Very cool. R2 is connected to its own PC respectively, as you can see right here. Okay, so I get the configurations out the way. I'm gonna start pinging things. For example, I will start with R1 first. So I'm gonna ping 2, 6. So this address should look familiar. This address is the address of the computer in R2, right? So I'm gonna go ahead and run this. So this address right here, I'm trying to ping PC2 right here, or the Ethernet interface they're a part of. As you can see, they're sending. It's taking its sweet time. And the success rate is 0%. Because R1, as we can see in the IP route, is only connected to R2 and PC1. It doesn't know that PC2 exists. So that's why the success rate is 0. And then we're going to try to ping the, if I recall correctly, we're going to ping router 2. So this is the IP address for router 2, if I'm correct. Yes, it's right here. Go copy that. Oh, I already typed this, so that's the IP address for router 2. We're gonna see if R1 can ping R2. Success. Boom. 100%. They're connected. They share the same subnet, so they can talk to one another. Now let's try R1 communicating to PC1, or the Ethernet interface of PC1. So if I recall, it should be right here. See if that works. See if FA00 works. Boom, success. It works. And this should be the same with PC2. So if we try to ping R1's FA interface, it's gonna do a little test, and we're gonna find out that it won't work, because like R1, it doesn't know that this interface right here exists. It's not physically connected. But if we ping, let's say, if R1 pings, no, if R2 pings R1, let me find the IP address real quick. Right here. So if R2 pings R1, it works. And if R2 pings its own FA interface, which is right here, it works as well. So the only ones that doesn't work is if R1 try to ping R2's FA interface, or if R2 tries to ping R1's FA interface. Okay, so next, so we know that doesn't work now. And then we're gonna try to ping PC1 to PC2, right? So to do that, we need to do a little configuring. I think in the lab it says We're not gonna configure any hosts, but I guess we're doing it anyways. So first, I'm gonna start with setting the IP address for these PCs. I'm gonna start with PC1. I'll do 1. The usual, but I believe since it's part of router 1, it needs to have let's see, I get a little lost in here. It should have the same, similar to this. This right here is the gateway, but the default gateway. But for clarity, I'm going to put a 0 right there. And the subnet mask is that. And then we put the default gateway. So we have the IP, the subnet mask, and then the default gateway to the router. I'm just going to check. And we're going to do the same over here. So instead of 1, we're going to do 2. And then put the subnet mask. And the default gateway should be, yes, this should be the default gateway. Oh, yeah, there you go. I'm going to click enter. It's going to check. So that one's good. PC1's good. But if we try to ping PC2 from PC1, destination host unreachable. This is because there's no router 1, as we said before, doesn't know that FA00 of R2 exists. So what we had to do is we had to set up a static IP route. Okay, to do that, we're gonna go ahead and go into R1 first. We're gonna apply a static route for both of them so they can go back and forth. So we're gonna do IP route. We're gonna set up a static route, and it's gonna be the destination. So the destination from R1, we want to go to the fast Ethernet of R2. So that's the destination we want to go to, and then the subnet mask. And now we do the IP of the neighboring router. So for R1, the neighboring router is just R2. And that's going to be this serial connection right here. Boom. So right there is our static route. Oops. Oh, I forgot to do config. Gotta make sure we're in configuration to change this. Inconsistent address and mask. Oh. I think what I did wrong is because I put a 1 here. We want to do the network address of the destination. So that should be 2.0, which is the network address, not 1. And then 255, 255, 255, 0. Boom. No errors. That should be good. So now, go to our, I'm just going to copy this and see if I can just edit it. Okay, so now we do the same over here. We edit this to be router 1's interface network address the mask is the same, and then instead of .2 it should be .1. Oh, gotta be in configuration. Oopsies. Boom. Now they're all set up, and I should be able to ping from PC1 to R1, and R1 goes to R2 and to PC2. So it should be ping address of PC2. And as you can see, the ping works. There's no unreachable host. And if I go over here, the address right here, ping PC1 also works as well. So that's very nice. Hey, it's me again. So while I was gone for a little bit, ta-da! I have this very cool tree looking network. So I have a switch right here, another switch right there, and then instead of just one PC, I have 3 in each network. So this is one network, this is another network. And because we have too many computers, a /30 subnet mask is not efficient enough. Won't have enough IP addresses. So in this network right here, we will need a -29 to allocate more space for more IP addresses. So a -29 would allow for 2 to the power of 32 minus 29, which is to the power 3, which is 8. So 8 IP address, but 2 of them are reserved for the network address as well as a broadcast address. So in total we only have 6 usable IP addresses, which is more than enough for 3 per network. Alright, that should be all. Thanks for watching.